This isn't just any comet, it's a traveler from another star system, and it's been keeping astronomers on the edge of their seats. The big question on everyone's mind is, when will it snow around 3I Atlas? Now, when I say snow, I don't mean the fluffy white stuff you build snowmen with. In the context of a comet, snow refers to a spectacular event called an outburst. This is when a comet, which is essentially a giant, dirty snowball of ice, dust, and rock, suddenly and dramatically brightens. It's like a cosmic fireworks show, and 3I Atlas is the star of the show we're all waiting for. So, what exactly triggers these outbursts? As a comet gets closer to the Sun on its journey through our solar system, the Sun's heat starts to work its magic. It warms the comet's surface, causing the frozen gases, like water, carbon dioxide, and carbon monoxide, to turn directly from a solid into a gas. This process is called sublimation. Imagine dry ice on a warm day, puffing out clouds of vapor. It's a bit like that, but on a celestial scale. This sublimation process creates a glowing atmosphere around the comet's nucleus, called a coma, and pushes dust and gas away to form its iconic tail. But an outburst is something more. It's a much more violent and sudden release of material. Think of it like a cosmic geyser. Pockets of super volatile ices, trapped just beneath the comet's crust, can get heated rapidly. The pressure builds and builds until ... boom. A massive plume of gas and dust erupts into space. This sudden release of material dramatically increases the amount of sunlight the comet reflects, causing it to appear much, much brighter from our vantage point here on Earth. For astronomers, both professional and amateur, this is incredibly exciting. An outburst gives us a rare chance to study the pristine, untouched material from the comet's interior, a chemical snapshot from the dawn of another star system. Now, let's talk about our interstellar guest. 31ATLAS. It was discovered in December 2019 by the Atlas Survey in Hawaii. The 3I in its name tells us it's the third interstellar object ever confirmed. The first was Oumuamua, and the second was to I Borisov. Unlike Oumuamua, which was a bit of an enigma, 3I Atlas looks and acts much more like the comets from our own solar system. When it was first spotted, it was very faint and distant, but as it's been traveling closer to the Sun, we've been watching it intently. It reached its closest point to the Sun, its perihelion, in March 2021. This was the prime time for a potential outburst. The solar heating was at its most intense, and the conditions were perfect for those trapped ices to sublimate explosively. Did it happen? Well, that's the tricky part. Predicting a cometary outburst is notoriously difficult. It's like trying to predict exactly when a specific popcorn kernel will pop. We know the general conditions are right, but the exact timing is a chaotic dance of physics and chemistry. Some comets, like the famous comet Holmes, have had colossal outbursts that made them visible to the naked eye. Others just fizzle and steam gently. Scientists have been using powerful telescopes like the Hubble Space Telescope and ground-based observatories to monitor 3I-ATLAS's brightness and activity. They're looking for any sudden jumps in its light curve, which would be the telltale sign of an outburst. They're also analyzing its coma for a sudden increase in specific gases, which could tell us what kind of ice was responsible for the event. Interestingly, 3I-ATLAS has been a bit of a tease. It showed some minor fluctuations in brightness, but it didn't give us the massive, show-stopping outburst some had hoped for around its perihelion. But does that mean the show is over? Not at all. Cometary activity doesn't just stop overnight. Even as 3I Atlas moves away from the Sun and back into the cold depths of interstellar space, it's still carrying that solar heat with it. The heat can take a long time to penetrate the comet's surface. Think of a baked potato fresh out of the oven. The outside might cool down, but the inside stays hot for a long time. This means that a delayed outburst is still a very real possibility. A pocket of volatile ice buried deeper within the nucleus might only now be reaching its tipping point. So, the outburst test for 3I-ATLAS is still ongoing. Astronomers will continue to monitor it for months and even years as it recedes from the Sun. Every observation is a piece of the puzzle. Why is this so important? Because 3I Atlas is a messenger from another world. Studying its composition, especially the pristine material ejected during an outburst, can tell us so much about the planetary system it came from. Are the building blocks of life, the organic molecules we find in our comets, common throughout the galaxy? Is the chemistry of other star systems semejante to our own? Every piece of data we gather from this interstellar traveler helps us answer these fundamental questions about our place in the universe. It's a chance to do comparative planetology, not with planets in our own solar system, but with the raw ingredients of a system light years away. The story of 3I Atlas is a perfect example of how dynamic and exciting modern astronomy is. It's a cosmic detective story, and the clues are written in starlight and cometary dust. Even if it never produces a massive outburst, its journey through our solar system has already provided a treasure trove of information. We've learned about its trajectory, its size, and its basic composition, all of which help us build a better picture of the population of objects wandering between the stars. So, as 3I Atlas continues its long, silent journey back into the interstellar void, we'll keep watching and waiting. The snow may still be yet to fall. The universe rarely gives up its secrets easily, but the chase is what makes the exploration so rewarding. What do you think? Did you get a chance to see 3I Atlas through a telescope? Let me know your thoughts in the comments below. And if you love exploring the wonders of the cosmos with us, don't forget to hit that like button and subscribe for more deep dives into the universe. Thanks for watching, and as always, keep looking up.